Thank you very much for giving me voice. Today I will talk about a recent article in the Energies, the use of hydrodynamic cavitation to improve the anaerobic digestion of waste from dairy cattle farming, from laboratory tests to large-scale agriculture biogas plants. There is need to find methods to intensify the anaerobic digestion process. One possibility is to use pretreatment techniques. Many laboratories confirm their effectiveness, but in most cases there is no verification work up to Professor Zielinski to carry out the industrial plants. A reliable and complete evaluation of new solution can only be carried out in plants that reflect operating conditions at a higher readiness technological level. This has a direct impact on the scientific value and above all on the high application value of innovative technologies. The aim of our research carried out under laboratory conditions and on large scale was to determine the technological and energy efficiency of the use of hydrodynamic cavitation in the pretreatment of waste mixture from dairy farms. It has been shown that hydrodynamic cavitation significantly increases the concentration of organic compounds in the dissolved phase. In the most effective variants, the increase in the content of these indicators was over 90% for both chemical oxygen demand and total oxygen comparison. The degrees of solubilization was achieved for 49 of chemical oxygen demand and 52 of total organic carbon. Under laboratory conditions, the highest effects of anaerobic digestion was achieved. This was the question, and we will see. The technology is based on the use of anaerobic digestion, are popular and widely used in many countries to produce renewable energy from substrate of different origins and characteristics. In this multi-stage process, biogas containing energy-rich methane and hydrogen is produced as a result of the biological decomposition of organic material by a specialized group of anaerobic microorganisms. Around 19,000 biogas plants operate in Europe. 10,000 are in Germany and 2,000 with Italy and France with 1,600. The correction of new anaerobic digestion system is very crucial. This is dictated by many factors, including unstable geopolitical situation that and high variable of fossil fuels and stabilize energy prices. This is never is reduction of greenhouse effect similar to European Green Deal. There are several factors contributing to the slowdown in the development of the biogas market. This includes the very frequent changes in laws required authorizations and environmental standards in this common area, as well as the fear of lack of installation by the local community. The most important aspect that significantly limits the intention of potential investors is the profitability and viability of this type of car plant. Currently, the viability of building anaerobic digestion bioreactor system is the models. Billionaire countries depend on the granting of subsidies, different types of financing, non-repayable loans, or preferential credits. It is therefore necessary to look for solutions, especially technological ones, that increase the economic efficiency and competitiveness of the metal fermentation process on the market. One of the directions that makes it possible to increase the return on investment and operation of anaerobic digestion plants is the utilization of organic waste. Heavily polluted wastewater from the food industry, sewage sludge, waste from agriculture, the fruit and vegetable sector, and the meat industry, as well as the organic fraction of municipal waste, acts as substrate in this process. Another way to increase economic efficiency is to use technologies and process units that increase the biodegradability of the substrate used, which has an effect positive on the quantity and quantitative composition of the bagasse produced. Research for this type of improvement primarily relates to the development, testing, and final implementation of different pretreatment methods. To date, many techniques have been analyzed to improve the susceptibility of organic substrate to degradation under anaerobic conditions. This could include combination and mechanical destruction, treatments with acids and bases, advanced oxidation, enzymatic hydrolysis, integration with ultrasound, hydrothermal depolarization, microwave heating, high voltage disintegration. Many of them are too expensive to industrial, only still in laboratory. One of such laboratory techniques is hydrodynamic cavitation. Recently, the prevailing the hydrodynamic cavitation, which is in fact a negative phenomenon that causes problems operational difficulties in technical plates related to fluid flows. It has been now widely pointed out that hydrodynamic cavitation increases the noise levels, amplifies vibration, disturbs the continuity of the flow, and intensifies cavitation erosion processes, which directly reduces the efficiency of the equipment and shortens its service life. Localized sudden pressure changes due to the cavitation can exceed typical value by a factor of hundreds, and where the resulting shocks are so strong that they can destroy almost any material. Attention has been paid to possibility of building and using hydrodynamic cavitation generators to classify biological processes, including the treatment of toxic and biodegradable wastewater, establish issues which stay graduated stage biodegradation. Hydrodynamic cavitation generator make easy and more precisely to achieve quiet cavitation conditions and intensities. The effectiveness of the solution has been subsequently confirmed, mainly on laboratory scale, but also, albeit rarely, in pilot plants and under near operational conditions in large scale installations. And the advantage of hydrodynamic cavitation is its economic aspects in terms of competitive operating and maintenance costs. Cavitation is the process of formation, growth, and subsequent explosive collapse of vapor bubbles, which is a consequence of phase change caused by a significant pressure drop at constant temperature. This dynamic transition from the liquid to the gaseous state, measured in milliseconds, can occur when the initial liquid temperature is between the triple point temperature and 30 critical temperature, and the temperature is temperature greater than the vaporization pressure. When the walls of cavitation bubble first, what happens during the collision, large amount of energy is released. It has been shown that cavitation dynamics and thermodynamic effects at elevated temperature and small venturi challenge dynamic decomposition of cavitation by thermodynamic effects and hydrodynamic cavitation considering temperature effects and the influence of temperature cavitating flows for optimal reaction conditions and to increase the intensity of cavitation treatment. Shock waves of high intensity and force are generated in the process media, which propagates at the supersonic speed of water. The local pressure exerted on the particles can exceed values of 1 gigapascal, and the local temperature can reach several thousand Kelvin. As a result, the vapor trapped in the bedding vesicles dissociates and generates free radicals of the hydroxyl ion and hydrogen type cations. Reaction with free radicals can take place in a collapsing cavitation bubble at the interface between bubble and cavitated medium. The effective generation of radicals per skewer of the process of oxidation pollutants molecules prior to the anaerobic digestion process. The phenomenon of cavitation thus comprises physical, thermal, and chemical effects. Physical effects contribute to the disaggregation of particles and the lysis of organic substrate due to the shock waves. Chemical effects are related to the production of highly reactive hydroxyl ions radicals and other reactive compounds responsible for the oxidation and lysis of organic substrates. The synergistic effects makes hydrodynamic cavitation process a promising and competitive solution whose implementation can improve the technological and economic effects of the anaerobic digestion process. The effectiveness of the use of hydrodynamic cavitation in the intensification biogas production has been successful on sewage sludge, biomass, and convection. Thus, Professor Dembowski decided to check in the convection of waste. The two stages were in the first work we are carried in laboratory scale. The existing batch and biogas plant, the basic hydrodynamic cavitation operating for the second stage with large tests were made. First was laboratory conditions. The objective optimization of hydrodynamic cavitation in batch type of methane, then to check if the similar is how the larger scaling test will be reflecting on how is the big mistake of the error of these two. Energy demand is in case of two stages. In stage two, of course, is much bigger than in first, but still he's looking how much energy is produced beside used. So the laboratory scale was carried in agriculture economy at the University of Missouri, while two were in agriculture paragraphs in Bauti. The organic substance generated the pretreatment of sources with hydrodynamic cavitation was a mixture of cattle slurry from barns and sewage from milking station of dairy cows. Mixture from cities in Bauti was collected and then channeled by means of collectors from the stables and milking station into to an underground retention tank with an active volume of 50 square meters equipped with a jet pump that ensured regular mixing of the contents. Agriculture waste was stored in this tank before being fed into the technical system of the agriculture biogas plant. The anaerobic sludge inoculum used in the laboratory tests came directly from the bioreactor of the agriculture biogas plant. The inoculum was therefore prepared and fully adapted to an organic substrate tested. The values of the basic pollution indicators contain the mixture of mineral solids and the carbon solid waste. The hydraulic multiplication and ashes was performed a hydrosonic pump in two variants. The first was 2,800 rotas per minute in a 16 kilowatts cavitator. The active volume of cavitators was 100 liters. The hydrocavitator inlet was located in the base and outlet or in the lead the container. In a hydrocavitation cycle, the container was filled with substrate and crushed by repeatedly flowing through the water under influence of centrifugal force. Depending on the variant, hydrocavitation time was between 0 and 10 minutes. Anaerobic digestion in station was carried out in reactors with total volume of 1 liter and an active volume of 0.5 liters, in which the bagasse and methane produced was monitored once a day. The modern chambers were mixed by mechanical stirrers with vertical axis and a capacity of 100 liters per minute. Stirring was started 24 times per day and on the hour for 50 minutes. First was introduced into the respirometers, and then an amount of cavitation stir mix station mixture was with inoculum was mixed, assume organic waste and conventional waste. The literature was 100 liter for obtaining anaerobic composition. The methane in true value was 20 square meters. The plant was operating the true plant, the industrial plant, was with organic load of 3 kilos chemical oxygen amount per square meter in a hydraulic retention time. This digestive starch was channeled into the digestive starch thickener, where it was separated into a solid phase with a dry matter content up to 20% and a liquid phase. The solid phase was recirculated into the fermentation chamber to a appropriate concentration of fermenting microorganisms in the anaerobic digestive process of 30 grams total solid per liter. The amount of biogas that was used with glycol as a catcher of the desulfurization process. Determined the experimental measurements, the efficiency of biogas production was determined in a system which no ex situ carbon dioxide absorption was used and in which the absorption with liquid was 3 moles sodium hydroxide solution. To determine the amount of methane produced in that technology line, an ex situ carbon dioxide absorption was used, whose carbon dioxide binding efficiency was estimated by the manufacturer to be over of 98%. To verify the result, obtained analyses were also carried out using a giant gas chromatograph with thermochemical detector. The biogas produced was collected directly from the respiratory bioreactor with a gas-tight syringe. In the chromatograph used, the Bulgarian gases were argon and helium at flow rate of 50 milliliters per minute. The device had columns operating of 70 degrees for a pack and module with cylindrical sleeves. Injection and detection was carried out at temperature of 150 degrees. Composition with quota GMF by gas analyzer and periodically with gas chromatography to verify the results. This obtained total natural, total phosphorus. The energy demand of the hydrocavitation process was calculated as the product cavitation energy into doses, given volume, and total volume of per heated substance. This methane was output, and methane was calculated by multiplying the maximum efficiency of gases metabolite production of the anaerobic digestion process per unit mass of chemical oxygen demand fed to the respirometers, which results from a first-order kinetics. The statistical talk value, however, varies with some limitation. Student test was used as a regression method. According to an available literature, the monitor effectiveness of the treatment were used cavitation dynamics. Then example was research certified the carbon dioxide in the disintegration process of aerobic granular sludge. The hydrodynamic decavitation process changes in organic matter content characterized by chemical oxygen demand, the dissolved phase. The process was evaluated and monitored by concentration and proofs contents were 9, 10 to 2 gram per liter. The cut concentration ranged increasingly from 4% to 15%. A significant increase of concentration of solubility of both chemical oxygen demand and total oxygen carbon was observed in the 10 minutes of hydrodynamic cavitation. The chemical was 16 per gram oxygen of liter solubility and total organic content was 5 grams per liter. With it obtained was solubilization of the composition of 40% and 36%. This shows the cavitation can collapse the influence of shear flows. Large energy input and short treatment time can only promote the agglomeration of the flux and not release the soluble material. Increased energy promotes disruption of the cell walls and high absorption of organic matter. However, low energy levels will lead to smaller particles, while high energy input uses larger particles due to rate flocculation, resulting in the structure that are resistant to anaerobic degradation. The HACCP treatment, the dynamic hydrocavitation treatment, can be influenced by many factors, such as the type, rotation reactor operating inlet pressures, rotation temperature of pH, and initial precipitant concentration. The total focus was determining the possibility of total yield biogas and methane and estimating the kinetics of the fermentation methane process. There is this due to advantages including stable and repeatable conditions, thanks to which its possibility to reliable compare and evaluate the results obtained, the ability to simulate different process conditions, which allows easy optimization of technological parameters, reliability as a measurement tool, ease of use, and the possibility of evaluating the influencing of inhibiting factors on biogas production. They are also frequently used to evaluate the efficiency of the pre-treatment process. The highest methane production of 227 grams per was measured in 160 with 2% dry waste sodium oxidation compared to anaerobic digestion catamine with degradation, where 190 milligrams was observed. Anaerobic digestion performed the respirometric batch reactors was determined. Studies have shown a positive effect of sonification on the kinetics of the anaerobic process and methane production. The highest production was achieved in the variants where sonication lasted 150 to 200 seconds and was between 540 to 560 grams per liter per gram. Methane production was from the disintegrator was 330 milligrams per gram. The expansion of the treatment process, which led to an excessive increase in energy digestion efficiency. The highest technological effects in terms of biogas and methane production were found in five, and second were used. The research results on the FS disintegration activated snatch using hydrodynamic cavitation also showed the maintenance of the cumulative biogas and the degree of snatch disintegration. So we have the hydrocavitation duration, and that this shows that 12 minutes was biogas the highest. However, the 12 minutes was 10 minutes very similar, only 1 milliliter and were higher by 12. So this shows the difference and showing that after 12 the FS is lowering. So this is the optimal in this case. This shows that other research shows this possibility envelope between chemical oxygen demand and amount increases does solidify carbon dioxide. Very positive, strong positive correlation were also found between the mass ratio of solidified and anaerobic granular sludge and the net energy gain. In the control variant, in the which was operated without, produced was content 61, and also 10 minutes were significantly higher than achieved. So 10, but 12 was too much. So this shows that in smaller scale, 10 and 12, but in bigger scale, just 12 and 10 minutes. This showed that cavitation can increase in 90% of content of indicators observed both, and celebration was fair 50 and 52%. So the very good example how to use the thresholds of flow demands to help other processes, also biological. Thank you very much for listening.